All right. So we'll start from these set of problems. And again, we'll start on the right-hand side and then we'll move to the left. So the right-hand side represents um, our new problems versus the left-hand side, which we did last week. All right, so we'll start with the first one. It says, Letitia said that the number line proves that -2 is less than -4. And the question is Letitia correct? So what do y'all think? -2 less than -4. Is she correct? Are we thinking or we just don't know?
She's wrong.
Okay. Tell us why.
Because -2 is closer to the positive numbers.
Okay. All right, perfect. All right, perfect. So she's wrong because -2 is closer to the positive numbers and and we know that the number line increases as we go to the right. Okay, so -4 is more left, so that makes it less. -2 is more to the right, so that makes it greater. Okay, so I would believe the answer here is D. No, because -2 is farther right than -4. Okay, good job, whoever that was. Next one, and again, people, please, we do require some level of participation here because we are both learning, and all of us are learning from each other. So please don't be shy. State your thoughts. There's no such thing as a bad thought or incorrect thought in terms of thinking. It's just sometimes we just need to process information a little bit more or get our rules correct or whatever it is. So if we want to move quickly through tonight, again, I will need that participation from you because I can't do it by myself. All right. All right, next one. Outside low temperature on Wednesday is -3 degrees Fahrenheit. The weather station predicted that Thursday's low temperature would be 2 degrees Fahrenheit, less than Wednesday's low. If the prediction is true, what will be Thursday's low temperature? So take a look at the important information in the question, and then let's come up with an answer. After we think about it. Okay, Ariana.
I think the Thursday's low temperature was -5 Fahrenheit.
Okay, good. Explain to us why.
Because in the problem it says the Thursday's temperature would be 2 Fahrenheit less than in Thursday's low, and the so the and the further away the number is, like for negatives, the further away the number is from 0, the smaller the number is, and so 2 away, so 2 less than -3 would be -5.
Perfect. Thank you. Excellent explanations as well. All right. So let's move on to the next one. This one, you see a little star there. It says algebra. So this is this is be like a ninth grade question. Okay. So let's see if we can rock this out. It says if x is equal to 6, if the, that's the first thing. We're reading properly. Okay. If the absolute value of x is equal to 6.7, what are the possible values of x? So here we're kind of introducing this variable called x. And all a variable really means is that it just represents a number. Sometimes we know what that number is, sometimes we don't. So anyone with any quick thoughts on that? If the absolute value of x is 6.7, what are the possible values of x? Now, if you look over to the left-hand side, we kind of did a similar problem last week and we got this correct. So those who were here last week, it's the same exact problem that we did, just using different words. Just set up slightly different.
The possible values of x would be negative 6.7 and 6.7.
Perfect. So again, New York State High School Regents, question number 23, done. And you're waiting, whatever grade waiting. All right. So concept of absolute value, distance of a number from 0. So they are always two numbers that have the same exact value, because every number on the positive side is reflected or has a opposite number on the negative side of 0. Okay. And last part of this, if the absolute value of x equals -5, what are the possible values of x?
The possible values of x would be -5. I mean,
Go ahead.
would it be I don't understand how it'd be. Aren't all absolute values positive?
Yes, they are. See the answer? See the answer?
Yeah, I see the answer.
Now think, does it make sense?
It makes sense.
Okay. What I did like is how you caught it. You caught yourself, because I heard where you were going with, and I heard you say to yourself, that doesn't make sense. And that's great. That's what you want. All right. Like that, it doesn't make sense. Like you do always trust in what you know, right? Trust in what you know. All right. Don't let a problem take your foundation away from you and make you shaky. Like we defined absolute value as the distance of a number from 0, and we said there's absolutely never have heard of a negative distance in our lives. That doesn't change because someone is asking you a problem that has a negative distance in it. That just means that that problem is invalid and there are no solutions to it. And that happens all the time in algebra. So once we begin to make that leap from, arithmetic into algebra, we will find equations or we find problems that have no solution just because they violate fundamental laws, fundamental rules, right? And so it's not that those rules are going to change, it's that that question just can't work, okay? All right, so let's move on. And so the next thing we want to do is just kind of, again, quick review. We're going to stay on the right-hand side, and hopefully we can get through this quickly before, and then we'll get into the new work. All right. Again, thinking about the concept of movement on a number line, negative 14 plus 5. So we would start at negative 14. I'll just do a quick number line graph just for those people who might not have been here before. And negative 14 plus 5. The pluses live on this side of the number line. This is 0. Minuses live on this side of the number line. So we're going to say, well, we're at negative 14. Plus 5 means we're moving to the right 5 spaces, which still will keep us on the negative side of the world. And so we're going to end up with negative 9. Okay. Then that's where we kind of started from. Then we moved into, well, let's look at creating some rules around this. Once we've done this enough times, we have some rules. The rule says when we're taking a look at numbers with different signs, we're going to take the number of the sign with the larger absolute value. So in this case, the number with the larger absolute value is the positive 13. So we know our answer is going to be positive. And then we're just going to subtract 13 minus 8. All right. And that's going to give us, what's that going to give us, people? 5. That gives us positive 5. All right. So this is, so we evolved from the number line into a rule that uses the concept of the number line to generate our answers. So again, if I went back to the number line, I would say start at negative 8 and then add 13 to it. Adding 13 tells me I'm going to cross over to the right-hand side of 0, which means my answer will be positive. And if I use 8 to get to 0, I have 5 left over. So my answer is 5. Next one, negative 15 plus 9. Again, with the concept of how we're doing it, we're taking it to look at the sign of the number with the largest absolute value. In this case, is negative. And then we're just going to subtract 15 on 9 from 15. Okay, and it's going to give us 6. So the beauty of this method is, notice how we are always just going to subtract the smaller number from the larger number, regardless of how it started in the problem. Regardless of how it started in the problem, we're always subtracting the number with the largest absolute value, always is being subtracted from, because we've already taken care of the sign. All right, so it's a two-step process. Take care of the sign, do regular subtraction. This is really going to be valuable when we now move into real numbers, because we're not going to get confused about the fraction pieces or the decimal pieces, because it's still just a regular subtraction. All we are now accounting for is what the sign is. And we get the value of the sign by taking the number with the larger absolute value. And that we see by sight. Like 13 is more than 8, 15 is more than 9. So therefore the sign is negative. Therefore the sign is positive. That's it. Moving on, we said that when we have a situation, so I should be on the right-hand side by now. I mean, on the left-hand side by now. So we're going to go to the left-hand side. When we have a situation where we have double signs in between numbers, so in this case, we have a plus minus. that if the signs are the same, so if it's a negative and negative, it gives us a positive number in between the signs. If it's a positive and a positive, it gives us a positive number. A negative and a positive gives us a negative sign. A positive and a negative gives us a negative sign. So what we basically said, if the signs are different, the sign now becomes, the one sign becomes a negative. If the two signs are the same, either negative, negative, positive, positive, the one sign becomes a plus. So here's what we're taking a look at in this case. We have two signs here, right? So based on our rule, two signs plus minus is going to become a minus. So this will become negative 13 minus 13. Again, we're taking the two signs between numbers. We're going to simplify them and make them one sign because we know how to deal with one sign. One sign is the number line all over again. So again, in math, we try to find ways to make things that may look challenging easy. We want to make, and we're using, but by using rules, not by conjuring up stuff, because sometimes we try to do magic in math and it doesn't work. So this is not magic. All right, this is like science. All right, we know there's a thin line between science and magic, and so this is, between science, right, between science and magic. So this is the science that says plus minus gives us a minus. All right, no magic in here. Okay, so negative 13 minus 13. We started negative 13, moved to the left 2 spaces. We ended up negative 26. Using our rule, if the two signs are the same, add the numbers together, keep the same sign. So two signs are the same, add the numbers together to get 26, keep the same sign. Why would we want to switch it? Okay. Ariana, you there?
I'm here.
All right, cool. So let me take this one. We got 14 minus negative 7.
Okay, 14 minus negative 7 would be 21.
Okay, take me through it.
Okay, so because of what you said about like if the two signs are the same, you would be adding it.
Mm-hmm.
It would be 14 plus 7, which
Okay.
is 21.
Okay, perfect. Okay. Thank you. All right. Ms. Vanessa, you there? Okay. I think I thought it might have been me. I think we have a delay between us. All right. So let me see. I'm going to do this one. Negative 25 minus negative 2. So I have negative 25 minus negative 2. So the first thing I'm going to do is deal with the two signs in between. So what does a negative and negative give me?
Positive.
Yes. Okay, yeah. So we're right there. So it becomes a positive. So we're going to rewrite it as negative 25 plus 2. All right. So now the signs are different. What am I going to do? What's the rule for when the signs are different? So just imagine we're starting at negative 25, which is here,
Yes.
and that's plus 2.
So you're going to subtract and keep the sign.
Okay.
So gonna go. So it's gonna go.
Okay.
It's gonna be 23, negative 23.
Perfect. There you go. So signs are different. So we're subtracting 25 from 2 gives us 23. And then we keep the sign of the number with the larger absolute value, which is negative 25. And again, the number line allows us to, like, sometimes we do stuff and we're like, our answers are like all over the place and we don't know how we got them. We just blurt out what comes out so quickly. To me, this makes sense. Like, because what you just did, I can do on the number line, right? I can start at negative 25 and then I can go +2 means move to the right 2 spaces, boom, boom. And I'm at negative 23, right? So our rule just simplifies what we could do by just getting on a number line and climbing left and right on the number line. All the rule does is if I have negative 1,000 plus 150, nobody wants to climb all the way to negative 1,000, right? So we have a rule that allows us to deal with any set of numbers. Okay. All right, let's move down here. Maybe I'll take this. Oh, wait, no, I don't want to take this one. Elisa scuba diving at 22 feet below sea level. She descends another 5 feet. What elevation is she at now? All right. So Lisa's scuba diving at 22 feet below sea level. She descends another 5 feet. Where is she? All right. Who else is on our call? Lauren, there with us? Ashley, I need that mic to be fixed. It was so great last week. Lauren, what'd you say? I can't hear you, Lauren. You said what?
I think maybe 27 feet.
You said 27 feet?
Yeah.
So she's at 27 feet.
Oh, no.
What does it mean if they tell you she's 22 feet below sea level?
She's below 0.
She's below 0. So what number would you use for 22 below 0? How would you designate that? What would you have to put there?
Negative 22.
Negative, perfect. Negative 22, right? And then she goes another 5 feet lower. So where would she end up at?
Negative 27 feet.
Right. There you go, Lauren. Negative 27. Okay. Okay. So that's, again, some things to pick up on. If you ever see a problem below sea level, right? So we always recognize, so this is the sea. This is at 0. And then we can go up and we can come down. All right. So this is sea level. Okay. All right. And that shows up again when we think about grade levels. This will show up 7th, 8th, 9th grade, where we have to be conscious of where the watermark is, so to speak. All right, next one. Gary's playing football. Now, right now, playing football, especially in an NFL. Actually, not playing football, but the concepts around coaching in the NFL are a major issue, especially today. Different topic, but everything's always connected. So Gary is playing football. In 2 different plays, he gained and lost yards for a total change of 0 yards. Which expression could represent the 2 plays? Ash, you want to put that in the chat for me? Hey, Miss Vanessa. Okay, so you were putting your answers in the chat. Eric, we have a camera on policy, so please turn it on. Any ideas, Lauren? Okay, I see you, Eric. We want something that gives us a total change of 0 yards, Lauren. 0 yards is what we're shooting for. Which equation, which equation there would equal 0? And we should go through each of them. Okay. All right. I got 2 right answers. Ms. Vanessa, I got Eric is good. Good, Eric. Eric jumped straight in and got is right on point. All right, let's go through each one. I got -8 plus -8. I'm going to take these 2. My plus and minuses gives me a minus. So I end up with -8 minus 8, which is -16. Okay, so I'm going to run through this quickly. I got 8 plus -8, so that's going to give me 8 minus 8. 8 minus 8, since I've been adding since I was in 2nd grade, is equal to 0. 8 plus 8, since I've been in 2nd grade, is 16. And 8 minus -8 gives me 8 plus 8 again, which gives me 16 again. All right, so B, those who sent in B, you're perfectly correct. Okay. All right, here we go. We got Ariana is looking straight down from a top of cliff with an elevation of 621 feet above sea level. Okay, so she's on some cliff up there. I don't know how she got there, but she's 621 feet above sea level. Somehow or other, Ariana in this cliff, looking straight down, she sees a submarine. I don't know why a submarine is below a cliff, but for whatever reason, it's there. And it's floating on the surface. So it's right there. It's, just chilling, right? And then this submarine suddenly dives 174 feet below the surface. So obviously something happened. There's an emergency. They gotta go. All right, Lauren. So the question is, what is the vertical distance from Ariana to the submarine? So Ariana is 621 feet above sea level. The submarine just dropped 174 feet below the surface. How far are they apart right now? All right. Any answers? Any thoughts? So I want you to think, okay? I want you to, so here's the thing with math, right? And I get this all the time, right? And this problem is a perfect example of it. I want you just to think about what is actually happening. I really want you to think about it. And I want you to forget all the rules, and just think about what's happening to come up with your answer. This is the surface, right? You got the surface, boom, it's right here. Here's the surface. Sea level, that's the surface. She is 621 feet above the surface. The submarine was at the surface, and the submarine sinks for 174 feet below the surface. How far apart are they right now? How far apart? She's 620 feet above the surface. The submarine is 174 feet below the surface. How far apart are they? So just think, like, just picture that scenario. Before you do any math, picture that scenario. And this should be a concept that you follow. I find that a lot of times we don't look to see what the problem is asking us, or not so much asking us, telling us. We don't look to see it. We just immediately plug in numbers. So I want y'all to not do that. I want you to actually, when you encounter a word problem, take the time to get an understanding of what the problem is really asking you before you start using numbers. Numbers are the last thing you should use. You should be really clear about what's happening in your word problem so you know what numbers fit where, right? So earlier, Eric, we talked about, being able to map different operations to different problems, right? And so this is one of those situations where I want to think about the problem and use my natural thinking process and understanding of life and the relationships of things like distance to each other to help us solve this problem. Okay, so the answer you gave me previously was like a math answer, like you just kind of took these two numbers together and just kind of brought them together, right? Because it seems like you should be doing that particular operation, but I don't think that was something that you actually pictured. Okay, so anyone? Ariana, you got anything for me?
Can you repeat the question?
It's right here.
Oh.
Y'all can see it, right?
the vertical distance.
Actually, Ariana, it's your problem. It says your name. You definitely should be giving me the correct answer to this.
Oh, so the vertical distance from the this I am the submarine would be 795.
Okay, how'd you get that?
So what I did was I did 621 plus 174,
Mhm.
and I got 795.
Okay, perfect. Perfect. All right. So if I was to draw, and I didn't do this on purpose, if I was to draw a picture of what this scenario looks like, and this is what I'm saying, that you want to get to the point that you can picture this yourself, right? Mentally make this picture. So you have the seawater, right? That represents the 0. She's 621 feet above. The submarine dives 174 feet below. If I subtract, and I'll tell you what the most common error is, most people subtract 174 from 621 because they know this is negative. So what they do is they say that 621 minus 174. Mathematically, that should really look like, because again, we're talking about distance, it should be 621 plus the absolute value of negative 174. All right. And now that gives us 621 plus 174, which gives us 795. Okay. So again, making pictures when you have word problems, best possible thing in the world to do. If you can create a picture of a problem, that's half the battle. That is half the battle. So take your time. All right. Sometimes we're in too much of a rush and we're like, oh, I got it. I got it. I know it. But we're not thinking through. Right. So when we're not thinking through is when we make those errors like 621 minus 174. And we ended up with, what was it, 4 something, I believe. Right. So I want y'all to always take your time to think through what the problem is really asking you. What is really happening here? Okay. I have 2 distances that I have to account for. I got the 621 that's moving up here. I got the 174 that's moving down here. The distance between them cannot be less than 621. That doesn't make sense. That would mean the submarine was flying. And that's not what submarines do. Okay. So always think about the answer. Like, what is, if you gave me an answer of, let's say, 4 something, what does that really mean? What does that really mean? If she's at 621 and now you're telling me the distance is like 4 something between them, that means the submarine is up here somewhere. It's not possible. All right. So moving on. And we get to the fun stuff soon. Well, this is one of the fun stuff. So this is a lower grade level. So again, these later ones are like kind of like at a slightly more advanced stuff. Like the one we just did is a little bit more advanced. This is definitely a little bit more advanced. This is like SHSAT stuff, 9th grade stuff, 8th grade stuff. Point M, not shown, right? So it's kind of dealing with algebra, is like working with stuff that you don't want to see, right? So this is definitely not arithmetic, right? So point M, which we don't know where point M is because they didn't tell us and it's not shown. But what we do know about point M is that it's 7 units away from point N. And so what are the two possible values of point M? So again, just like we said the last one, point M is not shown, but what we do know, it is 7 units away from N. So N is at -4. So N is 7 units away from it. And they tell us there are two possible values of N. So what are the two values of N?
I have a question.
Go ahead.
Not a question, but a statement. Shouldn't we count up from where we started from N? Or no?
Well, you're choosing to count up.
If it says not shown 7 units away, shouldn't we count up or
Okay.
down?
Well, which direction do you want to move in?
The right?
Okay, fine. Move to the right. Where do you end up at? Yes, Ariana.
The two possible values of point M would be -11 and 3.
Okay, excellent, Ariana. So now, Eric, and well, go ahead, Ariana. Explain to us, how'd you get that?
Okay, so how I got -11 and 3 was first I did -4 plus 7, which got me 3, and -4 minus 7, which got me -11.
Perfect. Amazing work today, Ariana. Thank you so much. All right. So just to get back to where you were going, Eric, you were heading on the right path, right? You were saying I should move up, right? So you were moving to the right, and so I'm sure you'd have ended up with 7. I mean, with 3 if you once you added 7 to -4. The problem though says there are 2. So that's why when you asked me, should I move left? Should I move right or left? I couldn't tell you, because you actually have to move in both directions because you need 2 values. If you move to the right, it's going to give you 1 value. That's going to be your 3 over here. But they're literally 2 numbers. And this is, can anybody tell me what concept is this? And we dealt with this concept earlier. What is this question really about?
Calculate the distance, I think.
Right. Yes, though there's a specific term I'm looking for that tells and that specific term is that it calculates the distance between a point and 0.
Variable.
What do we call that?
Variable.
I can't hear you.
Is it variables?
Well, no, variables are just any alphabetical or symbol or whatever to hold a number. But we talked about, didn't we talk about absolute value before? So when we talk about absolute value, there are 2 values. This is kind of connected to that, in that there's 2 values. If I'm at -4, there are 2 values that are equally distant away from 7 units away from -4. So we could actually make this into an absolute value equation. We won't do that to you, but by 9th grade we'll be doing that. But this is really what it's saying. It's saying if I use -4 as my center point, and I move 7 spaces to the left and to the right, I'm going to end up at 2 places that are equally distant from -4. And that's going to be -11 and +3. Okay. So we got 10 minutes left to get to the fun stuff. So here's the fun stuff. Adding and subtraction, rational numbers. So this is definitely 7th grade, 8th grade, 9th grade, SHSAT. All right. So those of you who are in lower grades, you're getting a head start on this stuff. Okay. So here we go. Now, what's going to make this thing easy is if you remembered our basic rules from earlier. So in math, the rules of numbers don't change based on the value of the number. So I find that a lot of times we think that if I'm dealing with positive numbers, it's like one rule, and negative numbers is another rule, and then fractions is another rule, and decimals is another rule. And the truth of it is they are all the same type of numbers, just shown and represented in different ways. So in many ways, the rules don't change. In many situations, the rules absolutely do not change. All right, so we're going to do a few and then we'll see how that comes to bear. So -9 plus 2.5. Okay, so I see these two numbers. They're no longer whole numbers. Not a big deal. I have my rules. My rule says if the signs are the same, add them together, keep the same sign. The signs are different, subtract, keep the sign of the number with the larger absolute value. That's it. So for -9 plus 2.5, what number has a larger absolute value?
-9.
-9. So what's the sign gonna be?
It would be negative. It would be 9.
No. I just asked you what's the sign gonna be?
Oh, it was gonna be minus.
Okay, negative, minus, whatever you want to call it. Sign is negative. I like to say negative or positive, but you can choose whatever you want. And then how do we get the value? What are we gonna do?
We're gonna
Go ahead. You have it.
we're gonna add.
No.
We're gonna subtract.
Okay, that's the other way. We're gonna subtract. Okay. And this is how we're gonna subtract. We're always gonna subtract the number with the higher absolute value. It will be subtracted from the number with the lower absolute value. It doesn't change. Doesn't matter. And let me point it out to you. Look at it in the original problem. The negative is with the 9 and the positive was the 2.5. What we're doing is we're saying we don't care about that. Our rule does not care about what started off with this and what's that. Our rule is saying if the signs are different, which they are, keep the sign of the number with the larger absolute value. So now I don't have to worry about what the sign of this is going to be. I can just revert back to regular basic subtraction of decimals, which tells me put a decimal point here, put a 0 here, and now subtract like you normally would. So this gives me 0.5. I borrowed from 9 to get there. So 8 minus 2 is 6. And here's my answer, -6.5. And I'm walking away. I'm going to lunch or dinner, whatever I want to do. I'm not going to stress about this. I'm not stressing because you got decimals here. And down here, I'm not stressing because you put fractions here. Those numbers, that doesn't change anything. We got the rule like 6 weeks ago. So when I see this, I'm like, I'm just going to apply the rule the same way. Okay, number 2. What's the sign of the number with the larger absolute value? I was saying, what is the sign of the number with the largest absolute value?
16.6
Okay. And what's the sign?
negative.
Look at it.
I mean positive.
Yeah, it's not a trick question. It's really just look at it. Like this is what makes it so easy. Like, I'm trying to show y'all something that's so easy, because sometimes we think about integers and negative numbers as being something that's so hard. And all I'm asking is just take a look at it. If I look at this, the positive number is larger than the negative number. So my sign, my answer at the end of the day is going to be positive. And now I'm just going to subtract 16.6 minus 12.7. And my laws of subtraction kick in. 6 is less than 7. I got to borrow from this 6, make it 5. 16 minus 7 gives me, what, 9. 5 minus 2 gives me 3. 1 minus 1 gives me 0. And my answer is 3.9. And again, I'm done. So the introduction of decimal values does nothing to my process. I don't have to make any adjustment to my process. Let's do these last two. I think we may have time. We'll see if we have time for more. All right. Same question every single time. Which number has the largest absolute value? Or what's the sign of the number with the largest absolute value, I should say. Anyone, real quick? Oh, yeah, I'm just asking you to look at it. Ariana? Bonnie? Miss Vanessa? I got two numbers, 12.84, 13.3. Which number is larger?
Uh, 13.3.
So therefore, what would be the sign of the answer?
It would be positive.
What sign do you see in front of the 13?
Oh, negative, sorry.
So what would be the sign of the answer?
Negative.
There you go, that's it. Again, our brains are trying to make this hard. Our brains are trying to make this hard. And Eric, I need you to follow it. Follow what we're doing. I'm taking a look at the number with the larger absolute value, and I'm taking whatever sign is in front of it, I'm taking that sign. So this 13 is larger than this 12.84 when it comes to absolute value. So I am taking the absolute value of the 13, right? And that sign is minus. So I'm putting a minus here. Whatever the answer will be as far as value, this negative sign will be right there with it. So it's a two-step process. First, identify the sign. Second, identify the value. Don't try to do both at the same time. Take the sign. Large absolute value is negative. Boom. Answer is going to be negative. Now, what's the value of the answer going to be? I'm going to do that. I'm going to get that from basic subtraction. 12.84. I'm going to add a 0 here. Borrow 3. So I get 6. Borrow from that. and I'm done. So Eric, you gotta like in this type of work, really gotta pay attention. It's a different way of looking at it than maybe some of our misconceptions may tell us we should do. And again, so I'm giving you a process. We will never, you have never done this before. You have never done that before. So why are we trying to do it now? And then this is the thing. We don't do this. When you were doing this in 5th grade, you never saw this. So we're not doing this now. We're not. We're just not going to do it. We're not going to subtract the larger number from the smaller number. We have never done it. Why would we start now? We've always subtracted the smaller number, from the larger number. That's what we're going to continue to do. It doesn't matter how it's written. This is unimportant. How they've written it is unimportant. We are always going to subtract the smaller from the larger. Now, what is important is that we first identify the sign of the number before we do that. And we identify the sign of the number by taking the number with the larger absolute value. Okay, we got 30 seconds to do the last one. And don't worry, like, hopefully you write this stuff down, study it, people. Take a look at it after tonight. We will be reviewing it again next week before we move on to the next set of questions. So just to finish off, we got -8.5 plus 5 1/3. Real quick, what's the sign of the answer gonna be?
A plus? I mean, negative,
Which one, Eric? Be clear.
negative.
Thank you. Why do you know it's gonna be negative?
It's gonna be a negative because the biggest number will be with the value.
Okay. Will be with the sign. All right. So the 8.5 is larger than the 5 1/3 in terms of absolute value. So the answer has to be negative. And now we're gonna I'm just gonna work over here. 8.5 minus 5 1/3. So this will be LCM is 6, so that'll be 8 3 6 minus 5 2 6. So that's gonna give me 3 6. So my answer is -3 1 6. Now I did that a little bit quickly because we have to end our session, but just to wrap it up again, notice that we don't like this, the way the problem is given to us. Once we recognize that we're dealing with negative and positive numbers, we just go into immediate, what's my rules? Forget about this. My rule says, take the sign of the number with the larger absolute value. I did that. Now subtract the smaller from the larger. I did that. And now put the two together, and this is your answer. You're done. You can walk away, take the rest of the night off, go have dinner, have lunch, play video games. You're done. And you're correct.